I work for Bloomberg, but I work in London. So I had the pleasure of the magic airplane when I spent 11 hours on the plane, and I landed 3 hours later. So be easy on me. I'm going to talk about the chaos engineering experience that we had in our team, the tool that we built, and that hopefully will be useful for you too. And on the menu, what I presented, prepared, is that I'm going to start with the problem, what we encountered, how we dealt with that, and then the second part will be about the powerful seal. And hopefully, by the end of this 20 minutes or so that we have together, you have yet another tool in your toolbox to help you spreading chaos. But before we jump into that, just a quick shout out to my team. This is the wonderful people that I have a chance to work with. To give you a little bit of background and why I'm here, we are building this platform called DTP. It's a microservices platform internally for other engineers in the company. I won't go into too much detail about that. If you're interested, we gave a talk at KubeCon Seattle 2 years ago. You can just YouTube that. But otherwise, it's a quickly growing Kubernetes-based platform that presented a lot of challenges to us. Special note for Kelvin, who's interning with us this summer and who actually wrote some of the features that I'm going to talk about in a minute. So we found ourselves with DTP 2-3 years ago. We were adopting Kubernetes. We found ourselves with like 1,000 moving parts, and we needed a way of making sure that things work together. And I don't know if you've reached that moment, but I definitely have, when you just go and try to find some solace in Google asking, OK, so why are the distributed systems so hard? And it's a little bit reassuring because Google tells you, or at least it used to tell you, that it's 49 million reasons not to worry about that because they're quite hard. But if I update the same slides now, it went up pretty much double. So if I extrapolate, by the time I retire, it's going to be pretty much impossible to work with them. But let's not do that. If we are a little bit more serious about that, I really like this quote by Lamport that I was introduced to by a friend. And I think this is pretty much the essence of the problem, that in a distributed system, when some computer you didn't even know existed is capable of messing up with your system and rendering your own computer unusable. And I don't know if people have the same feeling about it, but I find it difficult to find a better quote to pretty much describe that. You've seen it in the previous talks, but pretty much the bottom line is that everything is really plotting against you and trying to get you when you're not looking. The communications, the hardware, and the cascading errors are some of the main culprits. So given that it's a chaos conf, I'm expecting that we now kind of are in an understanding about this. The problem arises when you try to talk to someone who is not that technical, your manager, for example, about that. And I found that it's very useful to have an example ready with some very basic maths that can be quickly verified in your mind. And the example that I usually go with is something like this. If you assume that your servers are super reliable, let's say 10 years median time between failure, or average even, you only need like 3,650 of them to average one failure a day. And this is really something that gives people this kind of mental image that they need to understand that this is not a question of if, this is a question of when, because the scale is not that big for it to happen. If you have a moment later, check out the slides. They're from 2009. But there's a very nice section there about the back of the envelope calculations that everybody should probably be comfortable with. All right, so distributed systems are hard, obviously. We found some solace in Google confirming that. So what do? Well, surprise, surprise, we go and we do some chaos engineering. And that's pretty much what we did in our team. So the principles of chaos engineering, it's a nice website that also is manager-friendly because it's short enough for it to actually be read, probably. But you can do even better. You can pretty much summarize that in 3 bullet points, another useful tool. So we increase confidence in our distributed systems by introducing failure on purpose, and then we try to detect bugs and unpredictable outcomes. The key word here is really the increasing confidence. We are not really proving anything, we're just increasing that confidence by doing that. And that sounds good, and most of the time it's pretty easy to convince the technical people that it's a valuable thing to do. But if you ever run into trouble talking about that, here are 4 common things that I think are useful to have a counter-argument against. So I think the first one that you're most likely to encounter is some kind of variant of, okay, if it ain't broke, don't fix it. And it's a fallacy, and I think it can be pretty easily retorted by a combination of 2 things. The thing that we just proved, the thing that we just illustrated, the when instead of if, and also the cost of finding the bugs later versus finding them sooner. And that's usually enough to win this argument. The second one that usually arises is, okay, so we've got enough trouble already, why add to that? We already have a backlog that we can't fulfill. I found that it helps to say something along the lines, okay, so we're only going to limit that to, for example, the time when everybody's in the office, and we minimize the number of calls that people get during the night. Then the next one usually is some kind of thing about expertise, that we don't have that. Well, that's obviously no longer the case. There are tools easily available, and I'm going to be talking about one of them. The other guys have been selling to you other things all morning. And the last one is usually the production. And the production is always tricky. It's kind of the holy grail, obviously. But I think that if you at least sell a little bit of that running in production continuously, and then you ramp it up progressively, that is more realistic to introduce. All right. So that's the start. And then I wanted to share with you what we came up with. I think everybody recognizes this logo now. Like it was said in the first talk, at the beginning there was Chaos Monkey. So we wanted to use Chaos Monkey, but we needed something a little bit more customer. We were testing Kubernetes, so we wanted something that actually spoke Kubernetes instead of just taking the nodes up and down. And we came up with Powerful Seal. So Powerful Seal is trying to fulfill that. Don't ask me why it's called Powerful Seal. It doesn't matter right now. But it is indeed quite powerful. It's also trying to be very simple to set up. So basically, the setup means giving it access to the things that needs to be able to speak to. So it's going to need to speak to your cloud API. In our instance, that was OpenStack that we worked with. There is now an AWS driver contributed by the community too. Then you're going to need to be able to talk to Kubernetes, so kubeconfig, and then some kind of SSH connectivity to kill things via Docker on the nodes that you want to expose to it. So it's pretty easy to get started with, and it comes with, well, hopefully batteries included. It comes with 4 modes of operation. I'm going to talk about them and kind of show you what they feel like and what they look like. But in general, we wanted to kind of cover use cases varying from an interactive mode, when you kind of go and explore and you have tab completion and it feels a little bit, well, much like any other console tool. Then a label mode that behaves much more autonomously when you just mark things that you want to be killed, that you want killed by the seal. A demo mode, which is even more hands-off, where you basically pointed at some metrics and it kills things for you. And finally, the autonomous mode, where the actual serious work is done, where we know already what we're trying to break, and we just need a good way, flexible way of describing these things. So to give you like a feel of what it's like to use it, In the interactive mode, we work on nodes and we work on pods. Well, with all of the nodes, but in the interactive mode, you're going to be able to basically do things like list the nodes for this availability zone, for this range of IPs, for this thing in the name, for this particular state. And then you can filter them, take them up and down, and kind of explore the first approach. OK, my application is running. What happens when I manually take things up and down from this central console? And then the second layer is pods. So we already have the Kubernetes layer, in which we can list them again for like deployments, labels, pretty much all the usual stuff, namespaces, and then we take a sample of them and we crash them. It's set up so that actually we crash it through Docker so that it comes up as a failure and is restarted by Kubernetes for you. So that's the interactive mode. The second mode I mentioned is label mode, and it tries to be even simpler to use. So in this mode, you fire up the seal somewhere in your cluster, and then you go and you mark particular pods that you want to interact with a couple of labels. So in order to enable the seal with defaults, you can just mark something as seal/enable true. And then you can tweak some other things, like, for example, the probability of it being killed. You can tweak the days and time of the day so that you can satisfy that previous thing when you try to convince your manager it's a good idea. The third mode I mentioned is the demo mode. And in this case, it's a new addition. In this case, you basically pointed at hipster logs, hipster metrics, sorry. And then we have a little algorithm that tries to be a little bit clever to figure out what's actually worth crashing for you. So it looks like things like CPU, RAM usage, and tries to make assumptions about, OK, if it's busy, then it's probably important, so let me kill that. And you can tweak it with just aggressiveness level so that it's less or more aggressive. But the idea here is to really just fire it up and have something quickly. And then the real work really comes in the autonomous mode. So the idea in autonomous mode is that you already know how your application is defined, what the weak points are, and you want to write scenarios that basically prove that the weak points are handled by the application. So scenarios are policy files in powerful seal speech. It's basically a YAML file following a certain schema that has two arrays of scenarios, one for nodes and one for pods. And then the seal goes and executes them. The idea behind the scenarios is that you match things, then you filter them out, and then eventually you action on the ones that are remaining. So in this example, we can imagine that you have two matchers, whether these are pods or nodes, doesn't really matter. It works the same way. You have one that resolves to ABC, then you have C and D in the other one. So we're going to turn that into a set to duplicate it. Then you're going to have a filter. We're going to see a few examples in a second, but a filter removes two of them, so we're left with A and C, and then we have the actions, and for the actions, we're going to execute them on all of the remaining bits. So to give you like an example of a real-life policy scenario, rather, it looks a little bit like that. So we have the matchers. They are a little bit different for pods than they are for nodes. For nodes, we can match on any properties that are available. For example, name of the machine, IP, group, availability zone, that kind of thing. For pods, on the other hand, we can list them either through an namespace or a particular deployment, or if we want to do something more funky, we can just have whatever labels that are available and match by that. So after that, we're going to have a set of pods or nodes, and we filter things out from there. So again, we can filter on properties, or we can filter on things like a random sample, whether it's a percentage or some kind of fixed amount, number, or probability-related things, There are also filters for day of the week and time of the day and stuff like that, so that you can implement the workday again. And then after that, we have the actions. And in particular, currently the actions for the pods are one. You can kill them. For the nodes, you can take them up and down. You can execute arbitrary stuff if you really want to, or you can delete them. And that's it, really. So it's pretty quick to get started with that. The usual kind of use case is that you discover some problem with your application. You can write a policy that crashes it in the right way, and then you try to fix it, and then you let that policy run continuously so that you can kind of show that your application is no longer prone to crashing because of that. The autonomous mode also comes with a couple of nice features out of the box. So it comes with Prometheus metrics. You probably already have a setup of Prometheus plus Grafana that are scraping your metrics, so you can just plug it into that, and then you can tweak your alerts to exclude the crashes, for example, that the seal is executing for you, or you can alert on the seal not working properly itself. It also comes with another new addition with a UI, web-based UI, so if you're not into command line, you can also click and play, start, stop, change the config, and see all the logs from a nice-looking Bootstrap UI as an alternative. And that's really what I have prepared about the seal. So you can go grab it on GitHub. We open sourced it last year at KubeCon in Austin. And I would be really keen to get feedback from people. We got some people who told us how they used it. If you can, please do tell us if you have success with that, or maybe even more importantly, if you don't, go tell us why. And yeah, don't forget to start the repo. So the conclusions that I have is that life is too short to worry about the next outage, so go make your own. And now you have one more tool. Go embrace the seal, please.